Okay, actually I'm gonna explain this
large scale. Right?
Yes, our theory of gravity is works like that. Destructions of fabricas per second. Destruction of fabricas per second. That's it. This is the whole theory. And what we are saying here is that basically when we have massive object, this from every direction, it actually destroys fabricas of space-time and reality, and this creates somehow something similar to flow. Similar. So basically, we have this observation of bending space and time, and then if we have 2 or 3 or 4 objects or a lot of objects, what will happen? Each one will act like a sink, and they will have their own basically flow. And then we have let's say galaxy or a system that this as a total, as a whole, will create an accumulative
pool.
Yes, pool of fabricas from universe to the whole system. And therefore, doesn't matter where this basically massive object is located in the system, the whole system will have an accumulative, it will act like a sink, an accumulative basically system to destruct, to basically have this situation. Now, what will happen? After a while, also these Akashani stars that we said, it will create it. Because this flow from universe, the dark energy, what we say is a quantum protraction, like creating fabricas by fabricas, it will create a fixation on this shape. So we should take that to the consideration as well. So it will convert to another kind of fixed basically shape, because this shape continues and it will create a basically more permanent shape, not immediately because if we remove one of these, immediately the bending will go back to normal. But if we remove all of this, the scars that created, it will remain.
For some time.
Yes, it will remain. Well, in my mind, it will remain forever. There is no reason to remove it because it's fixed. And basically, this flow of dark energy, even if it stops, basically the whole scar will remain there. Now, if we have galaxy stars, again this calculation will come into place. What we have, let's say we have another galaxy and then we create a system again. And we should calculate the whole basically system based on this theory of gravity that we have, destruction of fabricas per second in the whole system. And then we can distribute it based on the mass of these galaxies and understand that basically how these galaxies can move. Again, this bending and everything, acceleration of Newtonian gravity and time-space bending of the general relativity will be basically predicted by this theory as well. So yeah, this is the whole thing. So I think your question answered, right?
Yeah, but to have an exact distance dependence, you need formulas.
Distance dependent, distance, what will happen? In each cluster of galaxies, or each galaxy, we can calculate how many fabricas per second that area is consuming. That area together is consuming. So that's why it's not distance related. This system is not distance related. You can calculate even the whole universe. How many fabricas per second whole matter in, like all of the matter in the universe are eating every second. Right? So basically, we can consider each area, like for example this area, let's say, or this area, or this area, and calculate how many fabricas per second is eating up. You know, for example, let's say we have evenly 10 people in this room, and each of us, we are eating 2 burgers. If I actually calculate in this area that I have 3 people, we are eating 9 burgers. Therefore, it is not distance related, it is area related, which is actually R2 somehow, but the effect will continue. Like the effect will be calculated, like if I calculate the whole room, that 3 people still counting against the basically fabricas that we are losing every second. You know what I'm talking about? Like we can calculate each area.
Volume.
Yes, yeah, exactly, volume, and basically calculate it based on that. Therefore, the calculation of the galaxy and calculation of the cluster of galaxies will be different, but with the same equation. The equation will not be different. Fabricas, this is the formula of gravity. This is our formula of gravity.
So for one massive object, the acceleration decreases 1 over distance square. For one.
Yes, that's it.
But if you
so it will be Newtonian. It will be Newtonian, absolutely. And then when we have like a larger object, it will be like the total situation of that. Again, it can actually come up with the same result as general relativity, but in a galaxy, the result will be different even from general relativity. So we don't need dark matter at all. We don't need dark energy and dark matter in this theory at all. What we say is that, like number of fabricas per second distracted by this whole galaxy, therefore we have a sink as big as a galaxy, and the total sink will have a rotation like total sink. Just imagine that we have 10 sink in our jacuzzi, and then we have that 10 sinks will create a flow all together, and it will act like a sink, big sink. And like imagine that we connect 10 jacuzzis together. What will happen? The whole, like all of those will create another bigger system. That's why we can answer completely to what is happening like as dark matter or dark energy in the galaxies and cluster of galaxies, just with the simplest formula without adding any constant, without adding anything, removing anything. You know, universe works like that. Universe works like really simply. If you have an equation that has 10 parameters, you took something wrong. You are calculating a shadow. This is simple. And it can actually come up with Newtonian and Einstein gravity both in larger scale, because it will show the time-space bending, it will show Newtonian law, it will show dark matter, it will show everything. Just that. Destruction of fabricas per second.